Hi Geometry! We're here today to talk about area. So what is area, you ask? Area is the space covered inside a figure. Do not mix it up with perimeter. Perimeter is the outside, area is the inside. So if you look at the letter K I have here, all of this that I shaded in blue, that makes up the area of the letter K. Now with our basic shapes, our basic quadrilaterals here and a triangle, there are formulas to help us find the area of these shapes. So the first thing I've done, you can see, is I've labeled the bottom of every single shape as the base. Okay, so next we need to find the height of every single shape. Okay, I went ahead and added in the heights. Now remember, this is review, so I'm going a little quick, but the height and the base have to meet at a right angle. That's how you know something is the height. Now in the triangle, I put the right angle in. The right angle wasn't given here, but since it's a rectangle, I know that it has 4 right angles in a rectangle. So I can assume that to be a right angle, which allows me to say that, yep, the height and the base meet at that right angle. Same thing with the square. A square has 4 right angles. So yes, this can be the height, this is the base. And a parallelogram, okay, the two sides do not necessarily meet at a right angle, so we have to go ahead and drop a height in ourselves, draw that in. Now you can connect anywhere you want between the two bases. So the shortest distance between the two bases is assumed to be our height. I like to put it at a vertex right there and drop it straight down. But again, my height and my base have to meet at a right angle. So same thing with the rhombus. You can drop a height anywhere you want, but I tend to go right to the vertex and go straight down and make it perpendicular to the base. That's what gets me the right angle. Same thing with the trapezoid. Now I could have put the height over here on this side, but I thought it was easier to see it if I put it on this side. So the height is perpendicular to the base, meaning they meet at a right angle. Okay, if you look at the formulas I put up, hopefully this is coming back to you now. We've got this idea of base times height, more or less, and we'll talk through what do I mean by that. So start here with the rectangle with me. The area of a rectangle is base times height. Okay, it's as straightforward as it gets. Now in a square, for me, I will also use base times height. Some people will make the argument that since the base and the height will be the same measure because it is equilateral, they could just take the base, multiply it by itself, or square it. So base squared or side length squared. That's true. For me, I don't really focus on that. I focus more on just base times height, but you are welcome to do either. Okay, moving on to the parallelogram. In a parallelogram, remember a parallelogram is a rectangle that's been pushed over. So therefore it should have the same area formula, base times height, as a rectangle. Okay, so we're 3 for 3, base times height. A rhombus is a square that has been pushed over. It is also equilateral, so it's still base times height. Now be careful on the parallelogram and the rhombus that you do not use this side right here. Okay, the leaning side, if you will, do not use that as the height. Remember what we talked about. The height has to be perpendicular or form a right angle with the base. So base times the height on the inside. The base times this height right here on the inside. Do not use the leaning sides. So these 4 right here are all, in fact, base times height. Now I'm going to back up to the triangle. So remember on a triangle, especially a right triangle, we should see that as half of a rectangle. So if the area of a rectangle is base times height, but I want to cut it in half, it should make sense to you that I've now put this divided by 2 on there. So how do you find the area of a right triangle? You find the area of the rectangle and you cut it in half. Base times height divided by 2. Okay, last but not least, we got to talk about this trapezoid down here. So a trapezoid, I put base times height, but I start it. Here's the problem with using base times height for a trapezoid. A trapezoid, the top base and the bottom base, they're different sizes. Okay, and every shape we have in the rhombus, the top base and the bottom base, they're the same. In a parallelogram, the top base and the bottom base, they're the same. In a square, top and bottom are the same. In a rectangle, top and bottom are the same. Well, in a trapezoid, the top and the bottom are not. The bottom, if you will, is bigger than the top. So how do I make this formula work? I have to average the top base, I'm calling that base 1, and the bottom base, I'm calling that base 2. I have to average them. What does that mean? I add them up and divide it by 2. I find the middle between the two bases. What's the middle length? Find the middle between the two bases, so average them up, multiply it by the height. So again, real quick, base times height divided by 2. Base times height. base times height, base times height, base times height. Really, this is base times height. It's just the average of the bases times the height. Look for the pattern. Okay, time for some quick examples. So on the first example, it's a rectangle, but there's no numbers here or here. Well, I can count the numbers myself. I need a base length and I need a height. Now I can either go base times height, or since this one's already all divvied up, I can literally just count the number of squares inside the shape. Okay, so whether you counted, right, counted every single square and got 27 that way, or just said, you know what, let me count 9 as the base, 3 as the height, base times height, 9 times 3. Either way, you get an area of 27 for number 1. Okay, number 2, base 12, height 5. It's a rectangle. It tells me right there. Base times height, the area is 60. All right, example number 3. So area of a right triangle, base times height. Here it is, base times height. 9 times 6 is 54. 54 divided by 2. Final answer, 27. Okay, number 4. It's a parallelogram. Area of a parallelogram is base times height. So 15 times 8, the area is 120. Done. Okay, pay attention to the area of the trapezoid. So the area of the trapezoid is base 1 plus base 2. Do that first. 22 plus 30 is 52. After you add the 2, divide by 2. So 52 divided by 2 is 26. Then you multiply it by the height and you get 416. So add first, then divide, then multiply. 416 should be the answer. Okay, composite figure. So remember what a composite figure is. A composite figure is 2 or more shapes put together. Okay, in this composite figure, my first shape is a rectangle, my second shape is a rectangle. So all I have to do is find the area of each rectangle and add them together to get the total area. The first rectangle is pretty straightforward. I had a base and a height. Base height, I got 75. The second one we have to do a little bit of work on. The 10 is my base, that is given, but the height right here or right here is not given. So to get that 3, I don't know if you saw this, but I took this 15, the entire height, and I said if this part went down 12, then this part had to be 3 so that these two numbers add up to 15. Right? The left side plus the right side has to equal the whole of 15. So subtract them. I've got a height of 3, so base times height, I've got 30 there. 75 plus 30, add them together. Final area for the composite figure, 105. Okay, so don't be overwhelmed by how this looks. I'm going to walk you through it. We're going to go backwards on this next example. So it tells me it's a parallelogram. The area of a parallelogram is base times height, but it doesn't want me to find the area. It tells me the area. So the area is 117. It's telling me or asking me to find the height. So take this 9, plug it in for B right there. That's what I've done. So B is 9, area is 117, and solve for H. How do I solve for H? I divide both sides by 9. Divide by 9, divide by 9. And then 117 divided by 9 gets me 13. So my height is 13. Next up, okay, again, we're going backwards. This time it tells me it's a trapezoid. So the trapezoid looks like this. That's what the formula looks like for a trapezoid. It's telling me the area is 144. It's not asking me to find the area. That's why this is going backwards, because it gave me an area. So plug the 144 into the A in the equation. Okay, the 14 and the 18, the numbers they gave me here, I've already marked them. They are bases. So I plug them in as base 1 and base 2. Now you might ask, how do I know which one's base 1 and base 2? It truly doesn't matter. But I let my top one be base 1, and I let my bottom one be base 2. But it doesn't matter. Add them up. When you add them, you get 32. 32 divided by 2 is where this 16 over here came from. So 144 is still my area. But now I've gotten to this I've gotten this one to the point of just saying, oh, divide by 16, divide by 16. So 144 divided by 16 is 9. So here, my height is equal to 9. And that's it for area.